Hi everyone, this is our last lecture in Unit 6, and today we're doing 6.7 Rates of Change in Trigonometric Functions. Rate of change is a measure at the rate in which a quantity changes with time. Speed is the change of a distance over time elapsed, and in symbol it is represented by s equals to d over t. Geometrically speaking, rate of change is the steepness of the slope of tangent in a certain graph. And the slope of tangent can be calculated with f of x2 minus f of x1 divided by x2 minus x1. The function and its tangent at x equals 2 is graphed below. In order to find the slope of the tangent, we need to use the equation that we just mentioned in the last slide, in which we have to use rise over run. In order to do that, we need two specific points on the graph. If a graph or a function has negative slope, it means that its rate of change is decreasing. If the slope is positive, it signifies an increasing rate of change. A horizontal tangent line will have a slope of 0. It means the rate of change is constant. Now let's take a look at an example. This is not from your learning resources. We have a function f of x equals to sine 2 pi x. This is a mathematical model of a vibration of the spring. F of x is the displacement of the vibration of the spring, and the x is the time elapsed. We're asked at what interval does the slope of tangent have a decreasing rate of change. We learned from previous slide that in order to have a decreasing rate of change, we need the slope of tangent to be negative. And it's very easy to see from the graph that the slope of tangent will be negative from when x is equal to 0.25 to when x is equal to 0.75. So the spring will slow down when the slope is negative. This occurs at the interval where x is bigger than 0.25 but less than 0.75. We have to prove what we just said. In order to do that, we have to use the slope of tangent equation. We have to find the slope of the tangent at the graph at the given interval, which we mentioned was between 0.25 to 0.75. The slope equals to f of x2 minus f of x1 divided by x2 minus x1. x2 is 0.75 and x1 is 0.25. At 0.75, the corresponding y value is negative 1. And then when x is equal to 0.25, the corresponding y value is 1. Therefore, we have a total final answer of negative 4, which is a negative number, so it proves that the spring will slow down when x is bigger than 0.25 but less than 0.75. That's the end of this lecture. Thank you.